Our system is somewhat unique in that all of our equipment can sit in an enclosure or a shelter in a safe environment because we take the laser out through an optical fiber up to the process stream, again, 300 to 400 meters away. We bring the Raman signal back to the spectrograph. The camera generates the Raman spectrum, and the chemometric model makes the predictions. As I mentioned, we can handle up to 17 streams. We set aside one stream as a performance channel that we look at once an hour just to check the instrument and let the user know that the instrument is operating properly. That takes about 10 seconds, and it's handled automatically. So we do this multiplexing sequentially. We look at stream 1, then go on to stream 2, 3, so on and so on, and then recycle. We can look at some streams more often than others, like on a blend header. You might want to look at the gasoline stream every other time, and in between that stream, you look at some of the component rundown streams.
In most cases, we use a Rittal server rack in the general purpose area for most of the analyzer. You can see the components shown in the previous block diagram along with their supporting equipment placed in the server rack: the monitor, the DIN rail, the computer, the keyboard, the optical multiplexer, and the PI200 analyzer, which houses the laser and the spectrograph.
However, we also offer a purged rack configuration to allow for hazardous area installations. The basic components remain largely the same, but the computer location and DIN rail configuration may be somewhat different.
In contrast to the online system, the lab system is a downscaled design that sits in the refinery lab area.
You notice this layout doesn't have a multiplexer or a dedicated performance channel. Instead, it utilizes an autosampler to feed samples from liquid vials into a single sample point. This system is ideal for researching possible new application as well as model development.
Note the components are not arranged in a rack, but rather freestanding. The computer may be mounted on the back of the monitor screen, or it could be a freestanding desktop model, such as is shown in this drawing.
At the back of the cabinet, the DIN rail, lower right side, there will be a series of 11 breakers. They are the on-off switches for the analyzer.
The first breaker is a 10 amp breaker that either provides or cuts power to the entire rack. The breakers after are each assigned to a specific component.
These should be listed on the breakers themselves. If not, the figure to the right will show the order of the wiring.
With a purged system in the back of the cabinet, on the DIN rail's lower left side of the panel, there will be a series of 11 breakers. These are the on and off switches for the analyzer. The closest breaker to the back is a 10 amp breaker that provides or cuts power to the entire rack.
The breakers after are each assigned to a specific component. These should be listed on the breakers themselves. If not, the figure to the right will show the typical order of the wiring.
For a lab system, the PI200, the computer, the monitor, and the autosampler will each have its own power switch located on the component itself.